So last year, I ran a book club for the book Weapons of Math Destruction, M-A-T-H, Math, by Dr. Cathy O'Neil, who was a Wall Street data analyst during the 2008 financial crisis. And she wrote a book about how algorithms are secretly limiting all our opportunities in life and what we can do about it. And I really recommend the book, but if you don't have time to pick that up, I definitely recommend watching her TED Talk. So first of all, what is an algorithm? We think of algorithms as being especially mathematical or coding related, but an algorithm can be as simple as a recipe. So it is a series of step-by-step instructions towards some goal or end. So with the recipe, you get the ingredients list, you follow the instructions, then you will always get a perfect result every time you do it, right? That's how this works. No, just kidding. So we can also make mistakes. This is from a TikTok video of a young woman who tried to make banana bread for the first time, and one of the comments said, "Did you stick a toothpick in the center to see if it's done?" So some of the other comments ended up being more helpful, and from there she learned that she had accidentally replaced flour with powdered sugar. And I use it as an example because it shows that it doesn't matter how good your algorithm is, human error will find a way to throw it off. Now, not all algorithm issues are as transparent or easy to fix, so here's an example from the book. In 2009, the Washington, D.C. Public School District started using a new teacher assessment that basically boils down your entire teaching effectiveness to one number somehow, and then they used that to fire hundreds of teachers who scored low. And one fifth grade teacher named Sarah Wysocki, she got excellent reviews from her principal, her students, the parents, but the algorithm doesn't care about that as much as it cares about her students' reading and math scores, and not just good scores, but whether the test scores had improved from last year. And the fourth grade class had scores that had been suspiciously inflated. Unfortunately, when she appealed to the school, she didn't have any proof, and so the school denied it, basically shrugging their shoulders and saying, well, what can we do? That's just the algorithm. That's just math. You were treated fairly. And so the public school lost a good teacher, and a private school immediately hired her. So this is not isolated to education, with algorithms being used in pretty much everything nowadays. For this, Dr. O'Neil coined a term called weapons of math destruction, and that is for algorithms that are secretive and do harm at scale, so to a lot of people at once. I want to share just a few examples from the book, and she has many, 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 many more where this came from. So your car insurance rates going up as much as 800% compared to someone else may have less to do with your driving record and more to do with your demographic data and whether they think you're willing to pay more. People with addresses in poorer neighborhoods are often fed more ads for predatory payday loans and fewer ads for opportunities like jobs and housing, which is known as digital redlining if you would like to look that up. If you were charged with a crime, recidivism algorithms could punish you with extra time for future crimes that you are deemed likely to commit, but you haven't committed, based on things like your neighborhood and whether your family members have criminal records. And if you're looking at any of this, like, wait a minute, how is that a thing? I recommend reading the book because she explains very in depth how each of these things came about and why they make perfect sense from a business perspective, even if they're terrible for the consumer. So this next slide is the most important. Here we go. Harmful algorithms tend to punish the poor. They specialize in bulk and they're cheap. The privileged are processed more by people, the masses by machines. This is the one thing that I want you to take away from this presentation. We at Kalamazoo Valley Community College serve the masses. We serve underserved populations, and we use software to grade and judge those underserved populations, which is not always a bad thing, but we are meant to be a gateway for students to prepare for the wider world and be successful. But the software we use, if it's not used appropriately, can instead make us act as gatekeepers. So to help us avoid becoming gatekeepers, I want to share some myths that Dr. O'Neil would want us to know about learning software. So the first one is that this is only relevant to data scientists or the CEOs of evil megacorps. So basically, if you don't look like this, mustache twirling Snidely Whiplash, then this is not relevant to you. As long as you mean well, it'll be okay. And unfortunately, Most issues with algorithms are often mistakes, which means they're made by well-meaning individuals, Dudley Do-Rights just like us. And that's why a very basic level of algorithm fluency is very important. The second myth is that software algorithms are less biased than humans, but Cathy O'Neil tells us that algorithms are just opinions embedded in code. What does that mean? It means that they were created by humans, coders and CEOs and product developers, not educators and not people with educational interests at heart. They have business interests that may not coincide with ours. Likewise, if you're using AI, consider that a language model like ChatGPT was trained on the internet. Its training data includes social media comments and works of fiction. So can you think of anything that's less objective and more biased than social media and fiction? No matter what additional measures the creators use to try and make it less biased, it is always going to be biased towards its training data because that's how it works. So myth number 3, if I use the same software with every student in class, that automatically makes it more fair. And unfortunately, software often treats different students differently for reasons that might not be obvious or relevant. Just like with the impact assessment, the same assessment was given to every teacher, but Sarah taught 5th grade and the 4th grade scores had been artificially inflated. So it wasn't fair to her because the only way she could have come out ahead was to inflate her own scores. For an example that's relevant to us, we could think of Respondus Monitor and how when we record students as a proctoring tool, it automatically flags certain behaviors like noise or head movements or eye movements, and how it might be unfairly biased towards flagging students in certain circumstances, such as maybe having a different skin color, maybe the student has children and has to take the test in a louder, more chaotic environment. And so what you need to do is self-audit your software to make sure that it's actually fair. So something you can do with Respondus Monitor is to sort of randomly choose which videos to audit. You don't have to watch every single one because no one has time for that, but instead of always relying on the auto flag, maybe just check a random smattering of videos each time. So we're going to go through a software audit together and we're going to use this AI content detector. So an AI detector is supposed to be able to tell whether your student's content was written by AI or not, and what percent was AI and what percent was their own work. So we are going to start by asking ourselves a series of questions that Cathy O'Neil provides to us from the book to find out whether this software could potentially be a weapon of math destruction, or a WMD. And after each question, I would like you to pause the video and answer it for yourself. So first question, consequences. Does the software have potentially negative impacts on real people? Yes, of course it does. It is meant to catch cheaters, right? And so if you catch someone cheating, then that person should receive negative consequences. It's not an inherently bad thing that a software has consequences for students. That just means it's important to their education, and that means it's important for us to get right. So the next question is scope. Does this affect lots of people and/or whole groups of people at once? Yes, it does. So this could affect not only class after class, section after section, it could also potentially target certain demographics. So if you do some Googling on AI detectors in the news, you'll find references to it being more likely to come up with a false positive for students for whom English is not their first language. So it targets that whole demographic at the same time. So that is a big red flag. The third question is transparency. If it makes a mistake, could you easily see and fix it? And no, it is not very transparent. Let's say that I put my essay in there and it says that it is 90% AI, 10% my original work. If there's a mistake in there, do you know if it's mistaken by 50%, by 100%, by 2%? You don't know how mistaken it is, and you don't know how to fix that. So we are immediately 3 for 3 on the questions, and that means we should probably not proceed with using this in our classrooms. So what you could do is just stop here. There is no need to go any further because we are 3 for 3 and have successfully answered the question, is this a WMD? Now we have some additional questions from the book that we could get into, especially if this is a piece of software we've already invested in, or maybe it's a piece of software that you yourself are responsible for maintaining. And the first one is data. What kind of data is behind its decision-making? How relevant and or biased is that data? Now, you don't need to be an expert or a data science to answer this question. If you went to the website for this AI detector, you would find at the time that I did my investigation that it was built on a ChatGPT-like AI. So it was basically using ChatGPT to detect ChatGPT. And we know already that ChatGPT and other language models are biased. The training data behind ChatGPT is biased in its decision-making towards training data that comes from things like social media and from fiction. So it might be biased towards giving a more interesting and inflammatory answer versus an accurate, well-thought-out answer. The second question is about success. How does the algorithm define success? And is it a good proxy or stand-in for what you are actually trying to find out? So I'll explain this. What you are trying to find out, your definition of success for using this algorithm, is whether a student actually sat down on their computer and typed something into ChatGPT and copy-pasted the result to cheat, essentially. But think like the people who created this software, and do they have an ability to actually sit behind a student and spy over their shoulder and see whether they objectively used ChatGPT or not? They do not. They're asking one AI to detect a different AI. And so their definition of success, of whether something is flagged as cheating or gets a pass, is whether the AI calls it cheating. Compare that to things like Respondus Monitor or having a remote proctor watching a student on a video camera while they're taking a test. While that does absolutely have its own problems and controversies, it is a much better proxy for whether the student was cheating, because if someone is reading the student the test answers, you can directly hear that on the video. So these are questions that anyone can ask about any piece of software to help guide you towards whether it is a good use of software in the classroom. You can also download these audit questions at the website bit.ly/WMD-audit24, all lowercase. Here I have a little cartoon of Dudley Do-Right signing Snidely Whiplash's contract, and Dudley Do-Right says, "Say, how exactly do your algorithms work anyway?" And Snidely Whiplash says, "That's proprietary." Thank you so much for watching, and if you want to borrow a copy of this book, if you are KVCC faculty, you can get it from the Faculty Success Center. You can also get it from local libraries, including the audiobook or ebook.